The 5090 is bio, I think.
Sir, my bad. 5070.
अच्छा ठीक है, नहीं वो दोनों कर लेंगे, दोनों के अंदर कोई खास
Sure.
फर्क नहीं है, ठीक है. So it's pretty much, I mean the questions are the same, ठीक है. They don't actually make two separate questions anymore, ठीक है. They're exactly the same papers, बस पैटर्न डिफरेंट है. वो दोनों ही कर लेंगे, ठीक है. क्वेश्चंस बिल्कुल आइडेंटिकल है. अच्छा, so just one more second. अच्छा चलिए यहाँ से. We're going to start with the first question, and the first one is about it's obviously about the atomic structure. तो उसके अंदर वो कह रहा है कि there is B and it has a charge of -1. इसका मतलब है कि it has one extra electron, ठीक है. उसके पास one extra electron है. तो 18 electrons है, तो एक extra है, -1 charge है. So that means the number of protons is going to be 17. ठीक है, that's the first one. C के बारे में वो कह रहे हैं कि the number of protons is 18 and the number of electrons you can see over here, उसकी electronic configuration is given, that's also 18 plus वो neutral है, ठीक है. It's neutral, so obviously दोनों equal होंगे. Then you have 8 protons and you have 10 electrons, so 2 electrons extra हैं, तो इसका मतलब है इसका charge होगा, that's going to be -2, and the electronic configuration is going to be 2 and 8, ठीक है. फर्स्ट शेल में 2 होंगे और सेकंड शेल के अंदर 8 होंगे. फिर उसके बाद है कि उसके बाद वो कह रहे हैं डिफाइन द टर्म एलिमेंट. व्हाट इज एन एलिमेंट, ठीक है. देयर जैसा कार्बन है, कार्बन इज एन एलिमेंट. क्लोरीन है, दैट्स एन एलिमेंट. सो दे बेसिकली, हाउ डू यू क्लासिफाई एन एटम एज अ कार्बन एलिमेंट. हर एलिमेंट जो है ना अपने प्रोटॉन नंबर से आइडेंटिफाई होता है. उसके न्यूट्रॉन्स चेंज हो सकते हैं, उसके इलेक्ट्रॉन्स भी चेंज हो सकते हैं, ठीक है. योर इलेक्ट्रॉन्स एंड न्यूट्रॉन्स दे कैन चेंज. Electrons can be lost, they can be gained. Okay, you could form a negative ion, you could form a positive ion. So the electrons are not fixed. The neutrons are also not usually fixed. You can have isotopes. But the proton number is always fixed. So what's an element? They're basically atoms of the same type. Okay, what is that type? So they're atoms of the same type that have the same number of protons. And which is why they're going to have the same number, same electronic configuration and same chemical properties. And same chemical so that is what an element is. As the next one is the following are gallium atoms, and you're being asked to uh, figure out the number of protons. So the gallium atoms are given. The number of protons, just smaller number, that's the number of protons is 31. ठीक है. Remember, don't look कि उनकी position, ignore the position. In the latest periodic table, the position is different. The smaller number, just look at the smaller number and the bigger number. The smaller number is the number of protons. The number of neutrons is if you subtract the two. So if you subtract both of them, what is 69 minus 31? That's going to be 30 what? 38. Okay, that's going to be 38. And what's one second. And what's 71 minus 31? That's 40, I think. And the number of electrons, that's number of protons and the number of electrons are usually the same. So that's going to be 31 and 31. So let's move to the next Let's move to the next question. 1 second, sorry. One second. Yeah. Let's move to the next one. He's talking about rubidium, which is a group 1 element, and it has similar physical and chemical properties to the other elements in group 1. So pehle to quickly, just for quick revision, what are group 1 properties? Group 1 properties are, they have several properties. The first one is that they have low density. Then they also have, so what else do they have? It's low density. They have low melting and boiling points, relatively low melting and boiling points. That's the second one. They're very reactive, extremely reactive. Plus, they are soft. They can be cut with a knife. So these are all group 1 element properties. Predict how many electrons they are. So I'm just going to go back to question part A, which is predict how many electrons are there in the outer shell of a rubidium atom. So group 1 is going to have 1 valence electron. So that's going to be 1. Predict one physical property of rubidium which is the same as that of a transition element such as iron. Now transition, these are group 1 metals. Okay, group 1 metals are very different compared to transition metals. Transition metals have completely the opposite scenario. They have high density. These are your everyday metals, and I'm talking about transition metals over here. So they have high density, they have high melting and boiling points. These are the everyday metals that you see, like gold, silver, iron, copper, etc. So they have high melting and boiling points. There are 5 properties that you have to remember for transition metals. They have variable, they form colored compounds. And they're very good catalysts. And the last one is that they have variable charges, variable oxidation states. Okay, just oxidation states. But now he's saying what are the properties that, these are the properties that are different. These are unique. This property is unique to group 1 metals, and the other properties are unique to transition metals. Now he's saying one property which is the same. So what is same? The similarity is that they're both metals. So can anyone tell me what do metals have in common?
They're
Conduction
able
of
to conduct electricity.
Okay, so they have free moving electrons and they conduct electricity very well. Okay, that's one. Or क्या होगा? What could be the second one?
Good conductors of heat.
Okay, they're also good conductors. Sorry, one second. Where's the? I said they're good conductors of heat. So good. Both. It's the same reason. Good conductors of heat and electricity. I said both of them are basically very similar points because all metals have this structure that they have positive metal ions. All metals, they like to lose electrons. So they have positive metal ions in a sea of free moving electrons. So there are electrons, a bunch of electrons that are roaming around freely because metals like to lose electrons and they don't have anywhere to go. So the electrons are just freely roaming around. So because of these high speed electrons, they can conduct electricity very well and they can also conduct heat very well. An electron over here can gain energy and can very quickly move to the other side and transmit that energy. So they're very good conductors of heat and electricity. So, but one very important point is they're also malleable and ductile. Although this point wasn't needed, they just needed 1 point. So they're malleable and ductile because when you when you hit a metal, the metal lines, they get deformed. They can be deformed, and they can slide over one another. Okay, so these metal lines, they can slide past each other. When you and they can get D-shaped. Okay, this is what happens when you apply a force. But a lot of force needs to be applied for that to happen. But group 1 metals are very soft, so you can do that very easily for them. Now predict two physical properties of rubidium which are different to those of a transition metal. So this is where the difference is, which we have already written. It's low density, or we can simply write this. They have low melting and boiling points, and they have low density. Plus they're soft as well. So you can write three properties. Next one is when rubidium is added to cold water, a reaction suggests two observations that would be made when rubidium is added to cold water. So it's going to be the very reactive. Group 1 metals are very reactive. So it's going to be a very vigorous reaction, or you can say an explosive reaction would happen. Any other thing that would happen when rubidium is added to water?
Hydrogen gas is a
Okay, so but okay, that is correct. I mean, this is the reaction that's going to happen. An alkali is going to be produced, rubidium hydroxide plus hydrogen gas would be given off. This is the reaction that's going to happen. A very strong alkali would be produced. But he's talking about observation. What would you observe when hydrogen gas is produced?
Bubbles.
effervescence.
Okay, bubbles, effervescence is going to be produced, and plus low density. Uh, it's very low density. So that means rubidium would float on the surface, would float and phase on the surface. It would stay above the surface and it wouldn't sink. So that's another point. Next one is what would be the color of the solution of methyl orange was added to the reaction? What's going to happen to the color? As we've already discussed, it's a strong alkali. Does it even know what the color change of methyl orange is in a strong alkali?
Orange or yellow.
Okay. So methyl orange has two colors. It's a it's red orange, or a darker shade of red when it's acidic, and yellow or yellowish orange when it's in alkali. So in this case, it's a very strongly alkaline solution, so it's going to be yellow. And remember, there's another indicator which is phenolphthalein. You have to remember the color of that indicator as well. Phenolphthalein is colorless in acidic and pink in alkaline conditions. Write a chemical equation for the reaction. We've already done that. Okay, that's done over here. Put the group 1 elements cesium, lithium, potassium, rubidium, and sodium in the order of the reactivity with water. Put the most reactive first. Now remember, in group 1, reactivity, like this is group 1. It's lithium, sodium, potassium, rubidium, TK, and then I think it's cesium or francium. Now, which ones are the rubidium, lithium, cesium? TK, I need to actually refer to a periodic table. Just one second, so I can know the exact order. TK, just one second. Achha, so the right order is rubidium and then cesium. Okay, that's the correct order. So let's go back to where was our paper? Just one second. Okay, it was rubidium and cesium. That was the right order. Achha, can anyone tell me what happens? Is the reactivity going to increase or decrease down the group? क्या होगा?
Sir, I think decrease.
नहीं, it increases down the group. So why does it increase? Because they like to lose electrons, right? So if size increases, like cesium is much bigger in size, so it would be a lot easier to lose electrons because cesium, the electrons that need to be lost, that's really far away. So cesium would have a lot of shells, so the electron would be somewhere over here. It won't be attracted very strongly. So bigger atoms, they lose electrons easily. And remember, for metals, always remember for metals, for any metal in any group, reactivity always increases down the group. Okay, that is what happens for metals. It increases down the group. Hamza, this is not the reactivity series. This is just that when you look at metals, any group metals, okay, we discussed this. They're not talking about the reactivity series. They're talking about the fact that when you look at metals, the reactivity within a group always increases down the group. Okay, they become bigger, and if they become bigger down the group, it is a lot easier for them to lose electrons. And a metal always loses electrons when it reacts. और नॉन मेटल्स के अंदर उल्टा होता है. नॉन मेटल्स के अंदर it's always the opposite. Okay, the reactivity always increases up the group because they have to gain electrons. So iodine would not be able to gain electrons because iodine already has 53 electrons. तो उसका जो न्यूक्लियस है ना वो बीच में छुपा हुआ होगा. ठीक है, it would not be able to attract electrons from outside because it already has so many electrons. तो जो छोटा एटम होता है ना वो ज्यादा स्ट्रांगली इलेक्ट्रॉन गेन करता है because its nucleus is a lot more exposed. उसका जो पॉजिटिव न्यूक्लियस है. अच्छा, anyways, coming back to our paper, तो ये इसको ना लिख लो, ये मोस्ट रिएक्टिव नीचे वाला होगा. ठीक है, so it's going to be cesium, rubidium, potassium, Na, and then there is Li. Suggest one safety measure that would be used when rubidium is added to cold water. So probably goggles. I mean, there's the chances of it exploding when you add it to water. So that's one. And I can open the marking scheme just to check खास तौर पे इस तरह के जो general. Where's the marking scheme? One second. Just to be sure about these general. अच्छा, goggles, glasses, gloves, safety screen. ठीक है, so the chances that it might explode. अच्छा, यहाँ पे उससे ना बहुत सही दी हुई है. Bubbles effervescence was one. Flame भी दिया हुआ है, it could explode. ठीक है, movement पे भी एक mark दे दिया. That's disappears, that's one. ठीक है, floats वो हमने लिखा था. Forms a ball, explosion. तो he pretty much gave all these marks. तो yellow वगैरह तो सारा ठीक था. अच्छा, the next is deduce the formula of rubidium phosphate. So rubidium is group 1. So it's +1. Phosphate is PO4 -3. So क्या formula होगा? If you do crisscross, it's going to be rubidium 3 and PO4. Get rid of the charges. ठीक है, तो ये part हो गया. So moving to the next part, question number 3. वो है कि he's talking about carbon dioxide and silicon 4 oxides and complete the, और उसने वो melting points और boiling points सारों के बारे में लिखा हुआ है. The first thing I would like to explain is carbon dioxide is a simple molecule. It has a simple molecular structure. What is a simple molecule? A simple molecule is like you have carbon in the middle and there is oxygen and there is another oxygen. Okay? So carbon has a total of 4 electrons. Group 4 always shares 4 electrons. Okay, I said this. So 4 electrons. How do I stop this from happening once? Okay. Oxygen has a total of 6 electrons. Remember, in covalent bonding, what happens is covalent bonding का ये rule है कि group 4 is going to share 4 electrons, group 5 is going to share, उसके पास 5 electrons होते हैं, it needs 3 electrons, so it's going to share 3 electrons. Uh, group 6 is going to share 2 electrons because it already has 6 electrons, it needs 2 electrons. And 7 is going to share 1 electron. So oxygen is in group 6, it's going to share 2 electrons. So what would happen is, sorry, so what would happen is, कि ये जो चीज है, this would share and form a covalent bond with this molecule over here. And the same pretty much would happen with this. It would come and share a covalent bond with this, a double bond would be formed. And that's about it. That's the molecule, that's it. But the molecule is going to have exactly one carbon atom forming a double bond with oxygen over here and a double bond with oxygen over here. That's it. Okay? It's a simple molecule. The molecule इससे बाहर कुछ नहीं है, ठीक है? There's nothing. It's just one carbon atom and 2 oxygen atoms. And there are going to be other such molecules. So there's going to be another CO2 molecule. There would be another CO2 molecule. And the molecules would have nothing to do with each other. तो सिंपल कोवलेंट मॉलिक्यूल्स का जो स्ट्रक्चर होता है वो छोटे छोटे मॉलिक्यूल्स होते हैं, ठीक है? Here's one molecule, here's another molecule, but they would be attracted to each other very, very weakly. They don't have anything to do with each other. So the molecules would be moving around freely in all directions. इधर जा रहा होगा, उधर जा रहा होगा, हर कोई अपनी मर्जी से, they would be moving around. And there would be very weak intermolecular forces between them. Which is why mostly they have low melting and boiling points and they're mostly gases. या फिर अगर liquids होंगे, they're liquids that evaporate very easily, ठीक है? Like water molecules, they would tend to evaporate very, very quickly. So that's a simple molecular lattice or structure. But on the other hand, he's also talking about silicon 4 oxide. Now, silicon 4 oxide, if I compare it with silicon 4 oxide, which is SiO2, that's not a simple molecule. Okay? That's a structure that you have to remember. It's a giant covalent structure. Silicon also is in group 4. It forms 4 bonds. But what it does is it forms 4 bonds with 4 oxygen atoms. Balki isko simple. So it forms 4 bonds with 4 oxygen atoms. And those oxygen atoms then go on to form bonds with silicon atom again. And the silicon atom then forms 4 bonds with 4 oxygen atoms. And the structure just keeps on repeating. There's a silicon atom that oxygen would bond with another silicon atom that would bond with 4 other oxygen atoms. So it's going to be a giant structure. Okay? And it's going to be a giant interconnected structure. There is no intermolecular force. All of them are bonded to each other. It's going to be a very strong structure. This is called a giant covalent or macromolecular structure. And there's a strong network of there's a network of very strong covalent bonds. So there is no intermolecular forces. Whenever you see SiO2, that's just one giant structure. All of it is interconnected. So it's a network of very strong covalent bonds. And this is exactly like diamond. So which is why it has a very high melting point, because you would have to actually break a bond. Because if you have to melt it, everything is bonded to everything else. So you would have to break it. Unlike in a simple covalent molecule, you just have to break the intermolecular forces, which are already very, very weak or almost non-existent. पहले से टूटी होंगी, ठीक है? कि आप रूम टेम्परेचर के ऊपर भी ना वो गैस है, मतलब if this carbon dioxide molecule is moving in this direction, no one is stopping it. So the intermolecular forces are very, very weak. So I just gave you a description of the two types of covalent compounds. There's a simple molecule. Most of them are simple molecules, but then you have a giant covalent structure as well. अच्छा, physical state SiO2. What is SiO2 in reality? में SiO2 होता क्या है real world में? Anyone?
Sand.
ठीक है, so SiO2. Just one second. किधर चला गया? एक second. अच्छा, so the reality is SiO2 is basically sand, and it's a solid. It has very high melting points. Conduction of electricity, both of them are non-conductors. They are, मतलब ये भी same है, non-conductor. They don't have free-moving electrons. And this is a structure, giant covalent or a macromolecular. This is a simple molecular. छोटे-छोटे molecules होंगे. And then you have name the type of bonds that exist between the atoms in covalent bonds, and both of them are covalent. Explain why silicon dioxide has a very high melting point, because to melt you would have to break, या आप लिख दो कि large amounts of energy is needed to break strong covalent bonds. अच्छा, to break strong. अच्छा, be very clear with your answers, ठीक है? You have to be very precise कि आप किस चीज के बारे में बात कर रहे हो. इसका हम आंसर चेक भी कर लेते हैं कि how is it phrased in the marking scheme. Just one second. Where's the ये यहाँ पे. ठीक है, तो एक उसे एक ही मार्क दिया हुआ है कि bonds need a lot of energy or heat to break. ठीक है, या bonds are very strong. ये उसे लिखा हुआ है. तो हमने क्या लिखा था? We wrote down a large amount of energy needed to break strong covalent bonds. That's pretty much the same. As I explained, in terms of attractive forces between particles, by carbon dioxide has a very low melting point because they have weak intermolecular forces between the, जो भी मैंने explain किया था. Between molecules. फिर explain in terms of particles why carbon dioxide is a non-conductor of electricity, because they don't have any free moving, no free moving charged particles, no free moving electrons like in metals or graphite, या फिर ions or delocalized या mobile electrons or ions. So there are no charges that are moving around. Suggest a chemical equation for the reaction between sodium hydroxide and carbon dioxide. Now this one, आपके पास periodic table होता है. The periodic table is, ठीक है, let's say this is the periodic table. You have metals on this side and you have non-metals on this side. एक बड़ी basic सी चीज है, that is कि the oxides and hydroxides of metals, that's their basic. They have basic oxides, and the non-metals, they usually have acidic oxides. Or beach में ना, middle में ना, there are some that are amphoteric. अच्छा, so carbon dioxide, he's talking about NaOH, that's sodium hydroxide, that is a base. ठीक है, that is definitely a base. ठीक है, you already know, most of you must know, it's the most common base. NaOH, base या alkali कह लो. Any base that's soluble in water can also be referred to as an alkali. So you have a base NaOH, and he's talking about reacting it with carbon dioxide. So carbon dioxide is a non-metal, so non-metal oxides are acidic. So why is carbon dioxide acidic? Remember, ये जितने भी non-metal oxides are like any non-metal oxide, NO2 for example, sulfur oxide, phosphorus oxide. The reason they're acidic is that when they react with water, they actually end up forming acids like H2CO3. If you react NO2 with water, it dissolves in water to form nitric acid, HNO3, and also simultaneously it would also form. Simultaneously it would also form nitrous acid, which is HNO2. SO3 would also react with water to form H2SO4, which is sulfuric acid. Phosphorus oxides would react with water to form phosphoric acids. So remember this, that your non-metal oxides, these ones over here, they are acidic, and the reason they're acidic is because they, they dissolve in water to form acids. तो अब वो कह रहे हैं कि the reaction is with carbon dioxide. Now, when you do a reaction with a non-metal oxide, any of this, don't think of it as the non-metal oxide. Think of it as the acid. If you're being asked to write a reaction with CO2, think of it as a reaction with H2CO3. Think of it that way. You're not writing a reaction with CO2. You're actually writing a reaction with H2CO3. So it's an acid-based reaction. NaOH reacts with H2CO3. How is the salt produced? The salt that's going to be produced is the metal is going to replace the H in the acid. So it's going to be Na+1. तो मैं यहाँ पे ऐड कर देता हूँ. It's going to be Na+1 and CO3 is -2. Here you have a carbonate, that's CO3. Na would come in, and every time the salt is going to be produced in exactly the same way. So it's going to be Na2CO3. Crisscross करोगे तो it's -2 and +1. So Na2CO3. Plus water produced. So the acid-base reaction where you have water, but since we haven't added water to it, so don't add water to it. The actual reaction or equation would be this one. It's going to be this one. NaOH plus CO2. Sorry, इसके अंदर water produce होगा because it's a hydroxide. क्योंकि वरना वो H किधर जाएगा? There is an H as well. ठीक है, 1 second. How do I? So in this case, there is going to be.
Sir,
Yes.
can you explain why we're using CO2 as H2CO2?
नहीं, इस वजह से ना. Whenever you try to make a salt from, let's say you do a reaction with NO2, ठीक है? Let's say you do a reaction of a base like calcium hydroxide with NO2. That's an acidic oxide. Now you must know that NO2 जो है ना, that ends up forming these acids, nitric acid and nitrous acid. So when you're trying to write a reaction, you won't be able to figure out the products if you write a reaction with NO2. Instead, think of it as a reaction with either nitric acid. तो तब salt बनाना आसान होगा. How do you form a salt? The metal comes in, gets rid of the H, and takes it. So it's going to form calcium nitrate or plus H2O होगा. ठीक है? तो इधर भी कर लो कि think of NO2 not as NO2 but think of it as nitric acid.
Okay, sir.
So it's going to be calcium nitrate plus H2O. ठीक है? तो यहाँ पे भी exactly मैंने वही चीज ना, अगर वो SO3 के साथ कहेंगे, write a reaction with SO3 like a base plus acid, like you have potassium hydroxide reacting with SO3. Don't think of it as a reaction with SO3. Think of it as a reaction with H2SO4. तो तब क्या बनेगा? It's going to form the H would get replaced by K. It would form K2SO4 plus H2O. So get rid of this. It's basically the same reaction. Okay, so think of, it would be a lot easier to form the salt if you think of it as H2SO4. So about these, so coming back to this, Just 1 second. कहाँ चला गया? चल ठीक है, found it. Now coming back to this, ये याद रखना है, ठीक है, कि what do you do with non-metal oxides? Don't think of as non-metal oxides, think of them as acids. ये clear है सारों को?
Yes, sir.
Yes, sir.
ठीक है, तो अगली दफा ना P4O10 के साथ ना कोई रिएक्शन लिखने को कहेगा ना, think of it as phosphoric acid, don't think of it as P4O10. मतलब P4O10 के साथ ना समझ नहीं आएगा कि रिएक्शन क्या होगा, ठीक है, मतलब if somebody tells you कि there's a base, I mean you should know कि non-metal oxides are acidic. If somebody tells you calcium hydroxide, reacts with P4O10 और वो आपसे पूछेंगे प्रोडक्ट क्या है, तो आपने इसको बस सोचना है कि think of it as H3PO4. तो if it was H3PO4 तो फिर क्या होता कि H की जगह कैल्शियम आ जाता, it would be calcium and PO4. PO4 is -3, calcium is 2 plus, so it's going to be CH3 and PO4 plus H2O. तो ये काम करना है. अच्छा, next one. ये जो 5 है, name a type of chemical reaction in which carbon dioxide is produced from fossil fuels. कौन सा reaction होता है?
Combustion.
ठीक है, so that's obviously combustion. You burn fossil fuels. That's how you get carbon dioxide. Name the chemical process in which green plants convert carbon dioxide into carbohydrates. What's the name?
Photosynthesis.
ठीक है, this is obviously equation भी पता होनी चाहिए कि does anyone know the equation for this? क्या होगा? What are the reactants in photosynthesis?
Carbon dioxide and oxygen, 6 molecules each. So
Carbon dioxide and
water. I'm sorry.
ठीक है, carbon dioxide and water, and they end up forming glucose and 6 molecules of oxygen. और इसके अंदर क्या essential what is take, मतलब how is it an endothermic or an exothermic process?
Endothermic.
ठीक है, it absorbs sunlight because it has, you require chlorophyll for this. Now name the chemical process that does the opposite in living organisms, जो produce करता है carbon dioxide.
Respiration.
ठीक है, respiration, that's exactly the opposite of, इसी का उल्टा कर लो, that's respiration. ठीक है, अच्छा, so that's this part. उसके बाद है कि अगला एक तो ये पता नहीं कहाँ निकल जाता है. अच्छा, what is meant by the term catalyst? It's a 2-mark question. So a catalyst is, one thing is that it's going to speed up the reaction, right? Achha, it speeds up the reaction. What else? It's a 2-mark question. Can anyone tell me? और क्या करता है, मतलब किस तरह करता है?
Lowers down the activation energy.
ठीक है, lowers activation energy, remains unchanged at the end of the reaction. Achha, so what a catalyst basically does is that whenever you have a reaction, like if you have nitrogen which has a triple bond and it's reacting with hydrogen, now that's a very difficult reaction to do because her reaction ke andar what happens is that you have to break the old bonds. So the molecules are going to bump into each other, and you're going to give them enough energy that they collide with each other with such a strong force that the triple bond breaks. But the triple bond is very strong. That means it requires a lot of energy to break this triple bond. So that means it has high activation energy. So every reaction needs a bit of energy at the start of the reaction because you need to break the old bonds. पुराने bonds टूटेंगे नहीं, तो how would you form new bonds? So you would have to break those old bonds. And to get rid of those old bonds, a large amount of energy is needed. Now, what a catalyst does is it somehow makes it a lot easier to break these bonds. Okay, I mean, that is how it participates in the reaction. It remains unchanged, it doesn't react with it, but it somehow makes it a lot easier to break those bonds. So now the molecules don't need to actually bump into each other with a lot of force. क्योंकि पहले चाहिए थी force. I mean, they would have to be very energetic, but now they don't have to be very energetic because the catalyst is now playing a role. It's making it easier for the bonds to break. And if the bonds break easily, new bonds could be formed very quickly as well. And the rate of reaction would increase. So this is about a rate of reaction. Student, what does he do? Studies the rate of decomposition of hydrogen peroxide using the apparatus shown. And this is the reaction. Remember, this is the reaction that they are talking about. So a student studies the rate of decomposition of hydrogen peroxide, and what else? He's given you the volume and concentration. If you have the volume and the concentration, what can you find?
Moles.
You can find moles. You can do N is equal to C into V. I mean, that's what we are going to do. Moles is concentration times volume. So the concentration given is 0.1. They probably are going to ask about this in the next step. So it's 0.1 and the volume is 20 cm cube, but that should be in dm cube. So it's going to be 20 divided by 1000. Can anyone tell me what the moles are? It should be in dm cube. So it's going to be what? Is it going to be 0.0002 moles?
2 into 10's power minus 3.
ठीक है, एक zero ज़्यादा हो गया. 1 second. So it's going to be just 2 zeros, right? That's a 0.002 moles. Over 1 gram of manganese 4 oxide is used as a catalyst. Now this is a catalyst. I'm assuming it's a catalyst. I think they did not. They're saying I think that's the catalyst because it's not doing anything in the reaction. So let's say this. Hamza, mole per dm cube is concentration. Look at the unit. Okay, mole per dm cube is concentration. Cm cube only, that's volume. Clear?
Yes, sir.
ठीक है, खाली cm cube होगा, that's volume. Mole per dm cube, that's concentration.
Okay, sir.
Acha, student jo hai na, that's measuring the volume of oxygen gas that's given off. So initially at the start, remember, gradient is the rate. Start ke andar na, the gradient is very large, and then the gradient kind of becomes less steep. और फिर constant हो जाता है. That means at this point जब वो flat हो जाए ना, that means the reaction has stopped. शुरू में ऑक्सीजन गैस बहुत तेजी से बनी है, ठीक है, it's going up, but then it slows down and then it becomes constant. So the steepness of the graph, so you're saying when is the rate of the reaction the highest? Right at the beginning, ठीक है, that's when it's really steep. So at the beginning. So there's one method of increasing the rate of reaction using the same amounts of hydrogen peroxide and manganese 4 oxide. Acha, jaldi se batao, one method. I mean, there are 5 ways of increasing the rate of reaction. One method. What's that? How can you speed this up? Using the same quantity. Anyone? What are the 5 factors that affect the rate of reaction? Number 1, temperature. ठीक है, you increase temperature.
Insert pressure.
ठीक है. अच्छा, प्रेशर वुड नॉट बी अ फैक्टर क्योंकि प्रेशर मैंने बताया था इट डिपेंड्स ऑन गैसेस. ठीक है, कि अगर रिएक्टेंट्स आपके ना गैसेस हो तो रिएक्टेंट इज एक्वस, तो प्रेशर से कोई फर्क नहीं पड़ेगा उसे. लिक्विड्स एंड सॉलिड्स आर नॉट कंप्रेसिबल, तो प्रेशर इंक्रीज करने से पार्टिकल्स और करीब नहीं आएंगे. ठीक है, दे नॉट गोइंग टू बम्प इनटू ईच अदर बिकॉज़ दे ऑलरेडी वेरी क्लोज टू ईच अदर. नूर, इज दिस क्लियर?
Yes, sir.
ठीक है, so although pressure is a factor but not in this case. Remember, pressure is when the reactants are gases. ठीक है, so not in this case. 3 is catalyst. So what you can do is you can use a better catalyst as well, like magnesium. Forget MnO2, use a better catalyst. That's probably first is वैसे सबसे आसान था. Number 4 क्या है और कौन सा? There are two more ways of increasing the rate of the reaction. One is concentration. लेकिन आई थिंक वी कैन यूज कॉन्सेंट्रेशन. उसने कहा था कि चेंज नहीं करनी क्वांटिटीज. ठीक है, तो कॉन्सेंट्रेशन जो उसने दी हुई है ना, वी हैव टू कीप दैट कॉन्सेंट्रेशन. so we're not going to take that. And the last one is surface area. Surface area is that powdered substances, they have more collisions uh, and more frequent collisions. So what you can do is MnO2, you can make MnO2 powder. Although the state to bata hi nahi hai, so instead of using large lumps, you can use smaller, more fine particles of MnO2. So लेकिन सबसे आसान था टेम्परेचर ही लिख देते. दैट्स द वन. ये मैं देख लेता हूँ उसने और कौन से एक्सेप्ट किए मैं यहाँ पे. जस्ट 1 सेकेंड. अच्छा, इंक्रीज टेम्परेचर पाउडर्ड का उसने किया हुआ एक्सेप्ट. ठीक है, सरफेस एरिया, दैट्स इट. कॉन्सेंट्रेशन, ठीक है, ये दो उसने कहा हुआ है. इन दोनों में से कोई एक. ठीक है, सो प्रेशर वाली बात उसने नहीं कहा क्योंकि, और ये याद रखना, बी वेरी केयरफुल विद प्रेशर. प्रेशर does not apply to liquids or solid. ठीक है, make sure, keep that in mind. Concentration उसने कहा था वो अमाउंट कांस्टेंट रखनी है, तो you can't change that. कैटलिस्ट का एक मैंने कहा था वो उससे एक्चुअली नहीं एक्सेप्ट किया हुआ. इट्स did he or did he not? मैंने कहा था एक बेटर कैटलिस्ट यूज कर लो. इज दैट नहीं? अच्छा ठीक है, उसने कहा था कि वो वही रिएक्टेंट यूज करने, चेंज नहीं करने. सो विच इज व्हाई otherwise it would have been a, उसने कहा था क्योंकि उसने स्पेसिफिकली कहा था you have to use the same things, so which is why you can't do that. अच्छा, suggest one method of increasing the rate of reaction using the same. ये तो हो गया. Moving to ये वाला पार्ट तो हमने पहले ही कर लिया. Just 1 second. अच्छा, ये हमने निकाल लिया था 0.002 moles. हमने शुरू में निकाल लिया था. This one is use your answer to C1 in the equation to calculate the number of moles of oxygen. तो what's the ratio? एक के भी moles पता लग जाए तो सारों के moles पता लग जाते हैं. ठीक है, so it's 2:1, right? So that means if you have 0.002 moles of this, so according to the ratio, the moles of oxygen would be half of that. It's going to be 0.001 mole. And बस उसने यही कहा था, you have to find the moles and you have to find the volume at RTP. How do you find the volume? Volume of a gas is basically moles multiplied by 24 dm cube. So it's going to be 0.001 moles multiplied by 24, which would give you what?
0.024.
It's going to give you 0.024 dm cube. Unit नीचे लिखा हुआ है पहले ही. अब फिर what would be the effect on the volume of oxygen produced if the mass of catalyst was increased? Catalyst does not, nothing would happen. No change, nothing would happen. Remember, catalyst reaction को speed up करता है. It doesn't increase or decrease the quantity. It doesn't participate in the reaction. So whether you increase the mass of catalyst or you decrease the mass of catalyst, reaction की speed ज़्यादा हो जाएगी, कम हो जाएगी, but the end result is going to be exactly the same. The volume of oxygen that's going to be produced is going to be exactly the same. फिर वो कह रहे deduce the volume of oxygen that would be produced if 20 cm cube or 0.2 mole per dm cube was used instead of so deduce the volume of oxygen that would be produced. तो सिंपली डबल हो गया क्योंकि आपके मोल्स डबल हो गए। वो कह रहे ये मोल्स ये अगर यूज करोगे और ये यूज करोगे फर्क क्या होगा? पहले आप ये यूज कर रहे थे तो अब आपने कॉन्सेंट्रेशन डबल किए तो मोल्स डबल हो जाएंगे। N is equal to C into V। तो यू डोंट इवन हैव टू डू एनी कैलकुलेशंस। अगर 0.024 बन रहा है तब डबल बनेगा, इट्स गोइंग टू बी 0.048 dm क्यूब। क्यों डबल बनेगा? क्योंकि C into V करो ना तो द मोल्स आर नाउ आर डबल द प्रीवियस मोल्स। ये कितना आ रहा था? 0.002 आ रहा था, ठीक है। वी कैन डू द कैलकुलेशंस। 0.002 मोल्स आ रहे थे। concentration times volume is moles. This is now 0.004 moles. तो मोल्स डबल हो गए तो ऑक्सीजन गैस भी डबल ही बनेगी, तो इसलिए द आंसर इज 0.48। ये क्लियर है सारों को? दिस वन?
Yes, sir.
अच्छा, ये बस लास्ट कर ले। द स्टूडेंट कैरीज आउट अ सेकंड एक्सपेरिमेंट टू इन्वेस्टिगेट वेदर अनदर सब्सटेंस is a better catalyst than magnesium 4 oxide. Describe how the second experiment is carried out. You should state clearly how you would make sure that the catalyst is the only variable. और 3 मार्क का क्वेश्चन है। One thing is you change the catalyst, ठीक है? फिर से वही हो गया। Just 1 second. This is side पे कर लेते हैं। अच्छा, one thing is you're going to change the catalyst. Constant temperature दोनों experiments का। Same, you're going to use सारे variables constant होने चाहिए। Same volume of H2O2. You're going to use the same concentration of H2O2, ठीक है? All the variables are going to be constant. It's saying describe how the second experiment is carried out. Change the catalyst but keep the surface area the same. कौन सा catalyst use करें? Copper 2 oxide. But it should have the same surface area. मतलब उसकी same shape होनी चाहिए, same। अगर powdered use हो रहा था पहले तो अभी भी powdered होना चाहिए। So everything should be the same. And you should plot a graph. और वो कह रहे हैं कि बस ये the only thing that should change is and the same graph is going to be plotted. अगर वो better catalyst है तो वो ज्यादा फास्ट रिएक्शन होगा। एंड में कार्बन डाइऑक्साइड तो उतनी बनेगी बट इट वुड बी फास्टर। इफ इट्स अ वर्स कैटलिस्ट द रिएक्शन इज गोइंग टू टेक अ लॉन्गर टाइम, इट्स गोइंग टू बी स्लोअर। सो इट्स गोइंग टू बी एग्जैक्टली द सेम एक्सपेरिमेंट। ये याद रखना जब भी आप एक्सपेरिमेंट्स प्लान करते हो, यू चेंज द ओनली वेरिएबल दैट यू आर ट्राइंग टू इन्वेस्टिगेट। ऑल अदर थिंग्स दे हैव टू बी केप्ट एग्जैक्टली द सेम। इस वाले का देख लेते हैं कि 3 मार्क्स किस तरह डिस्ट्रीब्यूटेड है। अच्छा हाँ, सॉरी, एक जो सबसे इंपॉर्टेंट चीज हमने मिस की थी क्योंकि वो बीच में मेंशन नहीं हुआ था। मैंने तो सेम सरफेस एरिया ऑफ कैटलिस्ट लिख दिया था। द अमाउंट ऑफ कैटलिस्ट मस्ट बी द सेम एज वेल, मतलब वॉल्यूम, कॉन्सेंट्रेशन, मास ऑफ कैटलिस्ट वुड बी द सेम एज वेल, क्योंकि उसने शुरू में ना टॉप के ऊपर हेडिंग दी हुई थी कि 1 ग्राम कैटलिस्ट यूज हो रहा है। तो यू गोइंग टू यूज द 1 ग्राम कैटलिस्ट with exactly the same surface area, the same temperature, the same concentration, everything would be exactly the same. The only thing that would change is the catalyst. ठीक है? क्लियर है सारों को?
Yes, sir.
चलो ठीक है, ये मैं इधर लिख भी लेता हूँ कि ये कौन सा पेपर हमने किया। दिस इज ताकि नेक्स्ट टाइम उधर से कंटिन्यू करें। दिस इज March 16, 42 and we were on कौन से पार्ट पे थे? We have to do question 5 next time, so just a second यहाँ पे। So 0620 March 16 and we have to start with question 5 next time. ठीक है चलो ठीक है okay then. Take care everyone.
Allah Hafiz, sir.
Allah Hafiz.